My name's Jeff. I'm with MOSIMTEC. I'm a partner with MOSIMTEC. What we do is modeling and simulation consulting, a lot of management consulting, and I'm going to talk about the ERP emulator to conduct supply chain diagnostics, and that's a long title. Really what I'm going to hammer in is using simulation for integrated business planning. And so I'll try to cover the technical aspects, but also the business aspects as well, because I think the latter are very important and why we do what we do. All right, so some of the things I'm going to cover, talk a little bit about, really quickly about who MOSIMTEC is, where we operate out of. I'm going to do a little bit of review on ERP systems and MRP systems. That's going to be a review for some of you. It's going to be a mystery to others. Hopefully I can solve a little bit of that mystery by keeping it simple. And we're going to talk about the shortcomings of both ERP as a system itself, as well as using it for planning, and put planning in parentheses there. Then I'll cover the significance of why we did this, why we built an emulator, what it was used for, talk about the architecture of the model at a very high level, 30,000 foot level, and then go into the applications and then further use cases. So MOSIMTEC, we are a management consulting firm first and foremost, but all of our engagements deal with developing models, using models, a lot of simulation, heavy on simulation. We're based out of DC, but we've operated globally. And we've got industry partners down in Virginia with the VMASC. It's an ODU private public consortium. So we like to build models, and we like to help companies out. So what is ERP? So at its core, all ERP is, it's a database that manages business transactions. I mean, that's essentially what it is. No more mystery than that. A lot of components in ERP, and over the past 30 years of proliferation of external components, but at its heart, that's all ERP is. It's a way to track business transactions. So under the covers within ERP, Enterprise Resource Planning, if I didn't say that before, is MRP and MRPII, Materials Requirements Planning and Manufacturing Resource Planning. Once again, I put planning in parentheses because while they're great tools at doing what they do, which is managing data and managing transactions, the planning part is a bit of a misnomer. So what is MRP and MRPII? In essence, we have inputs, orders, forecasts, materials, and inventory goes into a plan, plans developed, and then orders are created in the material requirements planning. A variety of functions are used in the materials requirements planning. I mean, everything from just simple min, mult, max, reorder points to some things that are far more sophisticated, like least unit cost heuristics and other algorithms. So some of the shortcomings of these tools, the fact that ERP assumes that there are no constraints on your resources, no constraints on your equipment, no constraint, and when I mean constraints, I'm talking about capacity constraints, failure constraints. All of that is out the window with MRP systems and ERP systems. Also, the fact that there's no variability in these planning tools, that everything is fixed, it's a deterministic model, causes a lot of consternation on the planning side. I have a little history in developing these plans for manufacturing plants. I've seen it firsthand from mining organizations as well. The plan is as good as lost as almost as soon as it was created. And then lastly, it's okay that they're designed that way because they weren't really intended for planning and analysis in that sense. They're there to get the organization operating on the same level, communicating with the same data under the same repository. The original intent was not to build plans from that, but to get everybody on the same platform, the same data platform. So that's okay. What's not okay is continuing to use these tools in the same way that they have been using when there's so many other tools, particularly simulation, that can offer better insights and more closely track how the real system operates. So how's ERP used today in most organizations? It's used at two levels, master planning and then detailed planning. And unfortunately, and I was a victim of this and I was also a promoter of this back in the day in an earlier life, is that these are done in silos. They have different objectives. The people have different objectives that are building these master plans. They're done at different times. So getting these things and getting these people to communicate is important. Otherwise, chaos runs amok when people are doing their own things at different levels in there. So pulling people out of their silos, getting them on the same track of what those goals are, even if the sub-goals are different, and changing that level of detail so that it fits the problem are three important factors on making the master plan and the detailed plan more integrated. Some other shortcomings of ERP planning is the fact that whether it's a tractor plant, whether it's a mine, whether it's an emergency department, there's one thing that's in common with all of these, and that's the systems change over time. Why they change may be for different reasons. In some cases, product lines impact the systems, where the bottlenecks shift from. In other cases, there's just in general an unstable process to begin with. And then part of it, what I've seen even in those organizations that really are able to track down their bottlenecks with a fine-tooth comb, there are changes and learnings that happen at the work cell, work center station over time that may have not have been accounted for in the original planning. Learnings such as how to operate the equipment more efficiently. Learnings such as tuning it so you're reducing the level of quality failures on there. Those learnings can also change the systems. So with all of that, why go out and build the ERP simulator, except for, it's really cool, but why do that? I mean, why we do that is to cover those, to be able to, one, identify where the problems are, those problems of shifting bottlenecks, the problems of future planning with product lines or ore bodies, but also to get people on the same page with planning, to pull in that master planning and the detailed planning on one platform and one level. Even if that platform has multiple models, it's still on one platform. And lastly, I mean, the communication, of course, is good for the organization. It makes everybody feel good. It's smart. But at the end of the day, it's about the net income, the bottom line, the ROI, the NPV, however you want to calculate it. That's what it comes down to. And if you're not uncovering that value, and if you're losing the value by sticking with these old ways of just building the master plans and using the MRPs and ERPs, then you're actually hurting your business system more than you're helping it. So how we went about building it, and I know I apologize for the circles and the squares on there, but there's only so much I can divulge. But you'll get it. You'll get it after this. The architecture is basically built off of three things. You've got planning algorithms, you've got the order algorithms, and you've got the production algorithms. And that's essentially it. So the planning algorithms look at inventory. They make the decisions about whether to order, when to order, by how much to order. They are where that MRP logic resides. The order algorithms manage the orders that are coming into the location. And I use a lot of manufacturing references, but anywhere where there's requests for work to be that come in that use ERP data, this is applicable for. The production algorithms are isolated to the locations on where the activities occur. So the production algorithms are determining which orders are routed through which pieces of equipment or personnel. They're determining how much raw materials to pull in, and they are embedded within the location objects. And fundamentally, what was important about this design was the fact that because it's an object-oriented architecture, we were able to embed that logic into the agents, into the objects. So all the production algorithms are inside of the location objects. The order algorithms and the planning algorithms sit on top of the entire system. But what it enabled us to do is generate models from data, from data extracts out of the ERP system to instead of clicking and dragging each time that you wanted to develop a new supply chain model or a new manufacturing model, it's all driven from data. And I put this on here because it's not one size that fits all. I ascribe to the modeling ethos that there's no one model to rule them all. I mean, it depends upon the question, and it depends upon the data that you have at hand and what's going to fit for that particular subject. And so some of the scenarios that we were able to answer and develop out of that design were rebalancing of production locations, service level validations, service level agreements validations, and so on and so forth. The point of this slide, the point of what I have on there is the great thing about simulation is even though you're designing it to solve a particular problem or answer a particular question, there are so many other bolt-on questions that you can answer along with those models. So one model can actually answer multiple questions. And answering those scenarios, you have to develop constructs. So for our ERP MRP emulator, those constructs consisted of parameters, logic, and data resulting in outputs, and there's really only 3 outputs. I mean, no matter how you shake it down, there's only 3 outputs. There's throughput, capacity, and utilization, and everything off of those is a derivative. And some, that may need to sink in for a bit, but there's really only 3. All of those, everything else is a derivative from that. So why do we choose AnyLogic? The first thing is the level of flexibility. So we use several different simulation tools, but if there's a high degree of flexibility that's required, of user flexibility that's required, we always default to AnyLogic because you can build it from the ground up. And when I say build it from the ground up, I'm talking raw Java code. I'm talking getting in there and building the code from scratch, if you have to. And in some cases, the problems are so technically challenging that you do have to. What that also enabled us to do, that level of flexibility, was, as I said before, with the taking the data, we could instantiate the objects at runtime. So what that means is you come up with the configuration of locations, you come up with the configuration of products that are going in there, or just the list of products, all of that driven off of data. At runtime, all of it's created and ready to rock and roll. So you're not reinventing the wheel each time. You're not recreating a new model each time. The other aspect of it that may go unnoticed, which I think really gets more people using simulation, is the fact that you can integrate it with your own UI. We happen to use Excel a lot because the folks that we work with use Excel. I remember back in the day as a planner, you've got Oracle, you've got your ERP system at your disposal to extract from every time, but all my plans were done in Excel. And just about every Fortune 500 company, 1,000 company that we've worked with, somebody's got their own Excel model over there. It's ubiquitous. It's everywhere. We tried going with with some different UIs, but it always came back to the request for Excel. And with Excel, we're able to actually launch so on a technical note, we're able to actually launch the models from Excel, transfer the data that's on Excel to the models, let the models run, models finish running, that data is actually pulled back into Excel and or Tableau if that's what you use. But all done from Excel. So the flexibility in the VBA code in Excel is pretty marvelous in getting the AnyLogic models to run from that. And then lastly, something that we've only been doing in probably the past couple of years because we found an opportunity to do that is bolt-on applications. So optimization and other heuristics that may be written in a different language. We're not embedding them directly into the simulation model. The model's calling these as it runs. So let's say heuristics about where to send the product line down different routes within the production sequence, right? That could be externalized, however that's called, through R, MATLAB, or whatever other external software application that you might use. You can easily do that. So parameters are passed from the simulation into this bolt-on application. Application runs, returns back the outputs and optimization outputs back into the simulation. The simulation continues to run like that. So where do we go from here? What are the possibilities with using, and like I said before, this is probably more preaching on using simulation and AnyLogic for integrated business planning than it really is about emulating an ERP. The possibilities of doing it this way, of using this method of planning, are you can start pulling in your strategic plans and your tactical plans and operating them together and obviously answering different questions and running them at different times. But now you've got people working on these plans at the same level using similar tools and able to deliver a lot more insightful and granular-based answers than you were before with just MRP. And then going even further, in Industry 4.0, trying to automate as much of the decision process as possible. You can take the simulation software, and this is not something that we've done, but this is something that we've discussed and we'd like to get there. And this is actually not a new idea. This is fairly, this has probably been around for maybe a decade or more. The idea of using simulation to actually generate more precise lead times that are fed back into the ERP system to get better, better decision making, more aligned with what the real system is doing. But essentially what you have is you've got your fixed data where, like your work centers, your routing data, your setup times, all of that's already in there. It's in the simulation model. And then what's being fed dynamically in there and are changing from week to week or shift schedules, downtime, labor capacity, all of that so that you get a more accurate indication of what your lead times are for products coming back into the system or lead times of the product being processed as a whole. And that is it. Thank you very much. I'm open for questions.
There's more than one ERP or MRP system, obviously. So
Right.
What has been your experience in connecting your constructs with different systems?
So first we try to avoid connecting them directly, right? At least starting out. So the experience is as long as the data is formatted coming out of the ERP system consistent with how it needs to go into the model. That's all we care about is the formatting of that data. Some are a little easier than others, but it's really all about organizing that data as it comes out of there and getting it put in a consistent format so that the user is always going to do, when they do their extractions out of the ERP system, it's already aligned properly and can just roll into whether it's Excel or whether it's pulled directly out of a text file or what have you, it's all ready to go. So, I mean, I can't really say, SAP versus Oracle. I mean, those are the first two that come to mind. It's 6 of one, half dozen of the other. It's really just how you set up those data extractions out there. Yes.
Just on the surface, the ERP emulation seems to have, in my eyes, quite a bit of overlap with ALX, with AnyLogic. Can you comment on that, or?
So I can say that for the projects that we've used it so far for the emulator, ALX was not an option at that time. So is there some overlap? Yeah, absolutely. In some cases, ALX is not going to be an option. And I'll just leave it there.
Okay.
All right. Thanks.